successful and unsuccessful people do not really vary in their abilities, but they do vary in their efforts. So if you want to be successful, then you have to put in that extra effort to be successful. Okay, so with this positive note, let us start today's session. And in today's session we are going to deal with chapter 2 of class 9, Polynomials and Factorisation. So this would be an introductory video where I would explain you the basic concepts of this chapter. So now let us quickly get started. Firstly, let me give you a few examples. Now if there is a class test and your teacher says that you will be awarded 3 marks for each correct answer. Okay, so you will be awarded 3 marks for each correct answer, and suppose if you have written X correct answers. Okay, so you have written X correct answers. So how many marks will you get? You will score 3 into X marks. Yes, suppose you got 2 correct answers. Okay, you answered 2 questions correct. So how many marks do you get? You get 3 into 2, which is 6 marks. Here 3 is nothing but marks awarded for each correct question, and you have written 2 correct questions. Okay, 2 correct answers. So total you get 3 into 2, which is 6 marks. Here you don't know how many correct questions you have attempted, so we are taking it as X, and each correct question carries 3 marks, and you have written X correct answers. Okay, so your total score will be 3 into X. Yes. Now suppose each chocolate cost 5 rupees and I have purchased white chocolates. So how much should I pay to the shopkeeper? I have to pay 5 into Y. Yes, one chocolate cost 5 rupees and I have bought how many chocolates? I have bought white chocolates. So the total amount which I have to pay is 5 into Y. Nothing but, suppose one chocolate cost 5 rupees and I have bought 3 chocolates. Yes, so how much should I pay? I should pay 5 into 3, which is nothing but 15. Okay, here instead of 3 we are taking it as Y. Okay, so I have bought white chocolates, so I have to pay 5 into Y. Clear? Now suppose on your birthday you have distributed X chocolates to Y students. Okay, you have distributed X number of chocolates to Y students. So how many chocolates did you distribute in total? It is nothing but X into Y. Okay, in simple, in numeric form if I have to take, so suppose there are 4 students and you have distributed 2 chocolates to each student. So total how many chocolates did you distribute? 4 2s are 8. Yes, the similar thing. X chocolates you have distributed to Y students, so total number of chocolates you have distributed is X into Y. Okay, and we have also learned that area of square is nothing but what? Side into side. Yes, nothing but S square. Okay, and we have also found that perimeter of square is nothing but 4 into S. S is nothing but side. Yes, length of the side. Clear? So all these things which we have learnt are called nothing but algebraic expressions. Okay, so all these are called as algebraic expressions. Clear? So you have already learned this in your lower classes. So what does an algebraic expression consist of? You can see that an algebraic expression consists of a variable and a consonant. Okay, so this is nothing but a variable, and here 4 is called as consonant. Okay, so this is consonant. Clear? Now why is 4 called consonant? Because the value of 4 does not change, but whereas the value of X is variable. Variable means it is varying, so it can take any value. Okay, so you can take the side of square as 1 unit, or you can take side of square as 2 units, or you can take side of square as 3 units. Okay, so in the place of S you can substitute 1 2 3 and so on, depending on the length of the side of the square. Okay, so it varies depending on the square, but the value of 4 does not change. Okay, let it be any square, any length of the side, but still you take 4. Yes, so here this is called consonant and this is called variable. Clear? So these are called algebraic expressions, and you have learnt in your earlier classes. So algebraic expressions, as we have discussed, they consist of a consonant and a variable. And in cases like this, where we have distributed X number of chocolates to Y students, so you don't know the number of chocolates distributed also. Okay, so we are taking it as X. Here this X is called as arbitrary constant. Okay, it is called as arbitrary constant. Why? Because the number of chocolates distributed to each student is same, whereas the number of students can be different. So the place where you don't know the constant, you represent an arbitrary constant. Okay, so arbitrary constants you represent it by A, B, C and and so on. Okay, so you have learnt about consonant, variable, arbitrary constants in algebraic expressions. So now I have taken few algebraic expressions. Okay, so here you can see that 4x plus 1, 3x square plus 7x plus 5, x power 1 by 2 plus 3, x square minus 2 by x minus 1. All these are algebraic expressions. Now can you tell me what are polynomials? So the algebraic expression in which the variables have non-negative integral powers are called polynomials. Okay, so you should have non-negative integral powers. Okay, so non-negative integral powers. So what does this mean? So it means non-negative. That means you should have a positive power. Okay, since it is mentioned that it should be non-negative, that means you should have a positive power. Integral means it should be some whole number. Okay, so in positive integer, you can say it as positive integer. Why? Because positive integers are nothing but whole numbers. Yes, so we are not taking the negative part of it, we want only positive integral part. Okay, and the algebraic expressions where you find only positive integers are called as polynomials. Okay, now here you can see x is a variable in this expression. Okay, and x has power what? X has power 1. So this is an polynomial. Okay, so let us write here. So 4x plus 1 is a polynomial. Now let us come to the next example. 3x square plus 7x plus 5. Here x is a variable. Yes, so x has a power 2, which is positive integer. Yes, it is an integral, it is whole. 2 is whole. Yes, it is not a fraction. Now here x consists of power 1. Okay, 1 is also not a fraction, it is a whole number. Yes, and it is positive 2. So we can say that this number is polynomial. So 3x square plus 7x plus 5 is polynomial. Clear? Getting my point? Now here x power 1 by 2. Okay, this 1 by 2, x has a power 1 by 2, but 1 by 2 is positive. It is positive, but it is not an integer. Yes, it is not an integral part, it is a fraction. Okay, so this is not a polynomial. Okay, are you getting it? So even if it is positive, it is not an integral part, it is a fraction, so we cannot consider this as a polynomial. Clear? Now here in the last example you can see it is x square. Here 2 is positive integral part. So okay, now here you can see it is minus 2 by x minus 1. Okay, so this you can write it as x square minus 2. Here it is x power 1. Okay, so if I take this x power 1 to the numerator, it becomes x power minus 1. Okay, nothing but it is in the form of 1 by a power m, which is a power minus m. You have learned this. Yes, so x square minus 2 x power minus 1 using this. Okay, minus 1. You have minus 1 here. Okay, so here you can see this 2 is positive integral part, it is okay, but here this x has minus 1, which is negative power. Okay, so you cannot consider this as polynomials. Okay, this is how you choose an algebraic expression if it is a polynomial or not. Clear? So the only condition is it has to be a non-negative integral power. Non-negative means it should be positive. Always the power has to be positive, and it should not be a fractional part, it should be an integral part. Clear? So such algebraic expressions are called as polynomials. Now let us talk about polynomial in one variable. Okay, so polynomial in one variable. Now as you can see, x square plus 2x minus 5 is a polynomial. Yes, because it has non-negative integral powers. 3x cube minus 5x square minus 2x plus 6. Okay, 6y square minus 7y plus 2. 6xy minus 2x minus 6y. Okay, so here you can see that all these are polynomials because the power of the variable is non-negative integral part. Okay, they are positive and they are integrals. Okay, so but here you can see in this equation how many variables are there? Only x. You have only x as a variable in this polynomial expression. Okay, and here you can see there is only one variable, which is x. Okay, here you can see there is only one variable, which is y. Clear? And here you can see there are two variables, x and y. Okay, so here there are two variables, x and y. Clear? So now here the polynomials which are having only single variable, here you can see all these are single variables. So these polynomials, first, second and third polynomials are called as polynomial in one variable. Okay, since they consist of only one variable. Okay, let it be any variable, it can be x or y or z or t, but it should be only one variable. Then these polynomials are called polynomials in one variable, and the other polynomial, these type of polynomials, they are called polynomials in two variables. Now let us discuss about few terms regarding polynomials. Okay, so in that firstly let us discuss about term of a polynomial. Okay, what are terms? So here you can see all these are polynomials, they have non-negative integral powers. Yes, so now let us talk what is term of a polynomial. Okay, now here you can see that 5x squared, 2x and 5, each of these are terms. Okay, so what are the terms of this polynomial? It is 5x squared. Okay, this is one term, 2x is another term and 5 is another term. Okay, now here 4x cube is one term. Okay, 7x is one term and 12 is another term. Okay, and here you can see 7x square y square is one term. Okay, 2xy is the second term and 8 is the third term. Clear? So here you can see that every term is separated by what? It is separated by either plus or minus. Did you observe? Okay, so term is nothing but this particular thing. Okay, so and each term is separated by a plus or a minus. Okay, so these are called terms of the polynomial. Okay, each single expression, here 5x square, 2x, so all these are expressions and these are terms. Okay, and each term you can see they are separated by plus or minus. Okay, so here you can see there are 1, 2, 3 terms. Okay, separated by plus. Here you can see 1, 2, 3 terms separated by plus. Clear? So I hope terms are clear for you. These are nothing but terms. Okay, so now let us talk about degree of the polynomial. Okay, before that let us talk about coefficients of these terms. Okay, so now in these terms, now we are speaking about coefficients. Okay, now what is the coefficient of 5x square? Coefficient is nothing but the constant which is present before the variable in each term is called coefficient. Okay, so now if you want to find out the coefficient of x square, it is nothing but 5. Okay, if you want to find the coefficient of x, it is nothing but 2. Clear? So here also if you want to find out the coefficient of x cube, what is it? It is nothing but 4. Okay, the constant which is multiplied with the variable, it is called the coefficient. Okay, this constant is called the coefficient. Okay, so even without writing the terms also directly you can find the coefficient. Now tell me what is the coefficient of xy in this polynomial? Coefficient of xy is nothing but 2. Okay, the constant multiplied to xy is what? It is 2. So 2 is the coefficient of xy. What is the coefficient of x square, y square? It is 7. Clear? So now let us talk about degree of the polynomial. Okay, but before that firstly let us talk about degree of the term. Okay, now we have seen that 5x square, 2x, 5, all these are terms. Yes, so now firstly let us see what is degree of each of these terms. Okay, degree of the term is nothing but, now this is a variable. Yes, x is a variable, so the power of x is nothing but the degree of this term. Okay, so now degree of 5x square is 2. Okay, here also x is a variable. What is the power of x? It is 1. So degree of 2x is 1. Okay, now here 4x cube is a term and x is a variable in this term. Now what is the power of x? Power of x is 3. Yes, so degree of 4x cube is 3. Clear? Now come here. Now here you have two variables. Yes, so in this term you have two variables x and y. Now in this case the degree of this term is nothing but the sum of powers of both the variables. Okay, so here you can see you have two variables x and y, and x also has a power, y also has a power. So here the degree of this term will be the sum of the powers of these two variables. Okay, so here you have 2 plus 2 is 4. So the degree of 7x square, y square is 4. Clear? Now here 2xy. Now here also you have two variables in this term, x and y. Now what is the power of x? Power of x is 1, power of y is 1. Okay, so degree of this term is nothing but sum of the powers of these two variables. Okay, so 1 plus 1 is 2. So degree of 2xy is 2. Okay, now let us talk about degree of the polynomial. Okay, so this entire thing is a polynomial. Yes, so now you can see that the degree of each of the term you have found. Here degree of 5x square is 2, this is 1. Yes, now out of this, which term has the greatest degree? It is nothing but 5x square has the greatest degree, and the degree is 2. Yes, so degree of this polynomial is nothing but 2. Okay, so degree of a polynomial is nothing but the highest power of the variables. Okay, so let us find the degree of 4x cube plus 7x plus 12. Here you can, just by looking at it, you can say that x cube, here 3 is the highest power, so degree of this complete polynomial is 3. Okay, now in this example you can see you have 7x square y square plus 2xy plus 8. Okay, so here also you can see the highest power is definitely in this term, because you have x square and y square. Okay, and what is the degree? Degree is nothing but the sum of the powers of these two variables. Okay, so it is x square and y square, so 2 plus 2 is 4, degree is 4. Okay, in other words, the highest degree term is 7x square y square, which has a degree 4. Okay, so that is the degree of the polynomial. Clear? So let me give you another example. 8x cube y square plus 7xy plus 7x square y. Okay, now this is a polynomial. It has non-negative integers as powers. Okay, so here you can see each of these are terms. Okay, they are separated by plus. Clear? Now in this term you can see the degree of this term is nothing but, you have two variables x and y, and x has a power 3, y has a power 2. Okay, so the degree of this is 3 plus 2, it is 5. Okay, here 7xy, it has two variables x and y, and x has a power 1, y has power 1. So the degree of 7xy is nothing but 1 plus 1 is 2. Okay, and here also you can see it is 7x square y, x has a power 2, y has a power 1, so the degree is 2 plus 1, 3. Okay, so the degree of the polynomial is nothing but the highest of all these, so highest is 5, so degree of polynomial is 5. Clear? Otherwise, instead of checking for each and every term, by just looking at it you can see that out of all these, this term has the highest powers. Yes, so simply you will add these two powers to get the degree of the polynomial. Clear? So let me give you one more example. 7x power 5 plus 4x square plus 2x. Now what is the degree of this polynomial? Just by looking at it you can see it is a polynomial in one variable, there is only x as a variable. Okay, and here you can see the degree, here it is 5 is the highest. Yes, so the degree of the polynomial 7x power 5 plus 4x square plus 2x is 5. Clear? Now here we did not speak about the degree of these constants. Yes, so let us talk about it now. So you have 5. Now what is the degree of this constant? Degree of this constant you can write as 5 is nothing but 5 into x power 0. Yes, why? Because a power 0 is what? A power 0 is 1. Okay, so 5 you can write as 5 into 1. Okay, instead of 1 you can write as a power 0. Here, since everything is in terms of x, you will write it as 5 into x power 0. Okay, so now this is a term and it has a variable x, and the power of this variable is 0. So the degree of this constant term is what? It is 0. Clear? Similarly here 8 also you can write as 8 into 1, which is nothing but 8 into x power 0, or you can take it as 8 into y power 0, since you have two terms here. Okay, two variables here. So the degree of this term is nothing but 0, since the power of x is 0. Clear? So here the degree of any constant is nothing but 0. Okay, and this is called as constant polynomial. Okay, so 5, 8, 9, 12, all these are called constant polynomials. Okay, and the degree of constant polynomial is always 0. Now we have learnt how to find the terms in a polynomial, or how to find the coefficients of the terms in the polynomial, and how to find degree of the terms and also degree of the polynomial. Yes, now let us learn how to generalize it. Okay, so you have learned what is degree 1 polynomial, what is degree 2 polynomial is. Now what if a polynomial has degree n? Okay, what if it has a degree n? Now if it has a degree 1, it is nothing but of this form x plus 1. If it has a degree 2, it is of this form 2x square plus 5x plus 2. Okay, now if it has a degree 3, it is 3x cube plus 4x square plus 2x plus 1. Yes, so this is nothing but degree 1, degree 2, degree 3. Okay, highest power is 3, here it is 2 and here it is 1. Now what if you have to write a polynomial of degree n? So how do you write it? So it is nothing but you can write it in this form: an x power n plus an minus 1 x power n minus 1 plus an minus 2 x power n minus 2 plus so on. Okay, here an minus 1, an minus 2, all these are nothing but constants. Clear? So let me compare these two. So here it is nothing but an x power n plus an minus 1 x power n minus 1, an minus 2 x power n minus 2. Firstly, let us compare the variables. Okay, so here you can see the power is n minus 1, n minus 2, n minus 3 and so on. Okay, so here you can see 2, 1, the power will be 0 here, variable, the power of the variable. Here you can see the power of the variable is 3, 2, 1, that means it is reducing by what? It is reducing by 1. The same thing we have written here, the power is reducing by 1. Yes, the power of the variables is reducing by 1. Also, here the coefficients we are taking it as an minus 1, an minus 2 and so on. Okay, and the condition is that an should not be equal to 0. Why? If this an is 0, what happens? It becomes 0 into x power n. So this whole term becomes 0. Yes, 0 into anything is 0. So this whole complete thing becomes 0 and this polynomial reduces to which degree? It reduces to n minus 1 degree. Okay, there is no x power n here. So the highest degree is what? N minus 1. But we need polynomial of degree n. Yes, so that is the reason an should not be equal to 0. Clear? So the condition is an should not be equal to 0 and this is called polynomial of degree n. Okay, generalized form. Now what happens if an minus 1, an minus 2, all these are equal to 0? What happens if all these coefficients are equal to 0? If everything is equal to 0, now if an equal to 0, then this term becomes 0. 0 into x power n is 0. Now if an minus 1 is 0, then 0 into x power minus 1 is 0. So this is 0. So each term is becoming what? It is becoming 0. So 0 plus 0 plus 0, what does it give you? It gives you 0. Okay, so if an minus 1, an minus 2, all these coefficients are 0, then you get a polynomial called 0. Okay, and this is called as 0 polynomial. Clear? So when all these coefficients are equal to 0, so you get a 0 polynomial. Okay, the answer here it will be 0 and this is called as 0 polynomial. Okay, and here you can see it is an x power n plus an minus 1 x power n minus 1 plus an minus 2 x power n minus 2 and so on. So this continues till where? It continues till a1x plus a0. Okay, so nothing but here you can see an, this n value is decreasing, it decreases and it becomes 1 and finally it becomes 0. And here x power n minus 1, the power is also decreasing and it becomes x power 1 and this is nothing but this is a constant term, so you will have x power 0 here. Okay, so it is x power 1 and x power 0, since it is 1, so we are not denoting it. Okay, so this is the general form of a polynomial of degree n. Clear? And now let me ask you another question. Now what is the degree of 0 polynomial? It is undefined. Why? Because 0 you cannot express it as a product of any variable. Yes, it is meaningless. So the degree of 0 polynomial is undefined. Clear? Moving on to the next topic, types of polynomials. So depending on the degree of the polynomial, you can divide the polynomials into these types, and based on the terms, number of terms present in the polynomial, you can divide it into these types. Okay, so let me explain you clearly. So you have already learnt about 0 polynomial, we have discussed it. What is a 0 polynomial? If every coefficient in the polynomial becomes 0, then it is called as 0 polynomial. Yes, and what is the degree of 0 polynomial? As discussed, degree of 0 polynomial is undefined. Okay, so this is undefined. Clear? So this is the first type of polynomial, 0 polynomial whose degree is undefined. Okay, now what is a constant polynomial? Now 5, 7, 8, all these are constant polynomials. Yes, so we have discussed that 5 can be written as 5 into 1, which is nothing but 5 into x power 0. Yes, so what is the degree of this? It is 0. So the degree of the constant polynomial is nothing but what? It is 0. Okay, so this is the second type of polynomial. Clear? Now what is a linear polynomial? The polynomial whose degree is 1 is called linear polynomial. Okay, so this is third type. Clear? Now what is a quadratic polynomial? If the degree of the polynomial is 2, then it is called a quadratic polynomial. This is fourth type. Okay. Now cubic polynomial is nothing but if the degree of the polynomial is 3, then such a polynomial is called cubic polynomial, and this is fifth type. Okay. Now what if the degree of the polynomial is n? Okay, we have learnt polynomial of degree n. So what if the degree of the polynomial is n? It is called nth degree polynomial. Clear? So it is called as nth degree polynomial. Okay, so if the degree of the polynomial is 0, it is called constant polynomial. If the degree is undefined, it is called 0 polynomial. If the degree is 1, it is called linear polynomial. If the degree of the polynomial is 2, it is called quadratic. If the degree is 3, it is called cubic. If the degree is n, it is called nth degree polynomial. Okay, so this is based on degree of the polynomial. Now let us see the classification based on terms of the polynomial. Okay, now if there are only one term in the polynomial, if there is only one term in the polynomial, then it is called a monomial. Okay, so it should be only one term. So for example, you can take minus 2x, 5x, all these polynomials has only what? Only one term. Okay, now what is a binomial? In a binomial, if you have two terms, then it is called a binomial. Okay, so a polynomial with two terms. Suppose 5x plus 1, here you find two terms. Yes, in this polynomial you find two terms, so this is a binomial. Now what is a trinomial? If you find three terms in a polynomial, suppose 2x square plus 5x plus 1. Okay, here you find 1, 2, 3 terms in this polynomial, so it is called a trinomial. Okay, what is a multinomial? If in a polynomial there are more than 3 terms, okay, if there are 3 terms, it is trinomial. If there are more than 3 terms, it is called multinomial. Example, 4x cube plus 5x square plus 2x plus 1. So here you have 4 terms. Okay, that means more than 3. So this is multinomial. Clear? So based on degree, you can classify polynomials in this way, and based on terms, number of terms of the polynomial, you can classify it as monomial, binomial, trinomial, and multinomial. Now let us learn how do we represent polynomials. Okay, suppose if there is a polynomial 5x square plus 2x plus 1, and how do you represent it? You represent it as p of x. Okay, where this x is nothing but it tells you that there is a variable involved x here in the polynomial. Okay, suppose if there is a polynomial 3t square plus 2t plus 1. Yes, here you represent it as q of t. Okay, here t represents that there is a variable t involved in this polynomial. Okay, now suppose if there is a polynomial 2x square plus 5x plus 2. Okay, you can represent it as q of x. Okay, so this is how you represent polynomials. Okay, p of x, q of t, q of x, where this x, t, x is nothing but the variables involved in the polynomial. Clear? And you can see all these are polynomials with single variable. Yes, so you will later learn polynomials with 2 or more variables in detail. Okay, so for now we are only dealing with polynomials with single variable, and this is how you represent it. Okay, now moving on to the next topic, 0 of a polynomial. Okay, suppose if I take a polynomial x square plus 5x plus 4. Okay, now how are we representing it? We are representing it as p of x. Since you have x as a variable, you are writing it as p of x. Okay, so now if I want to find out p of 1, how do I do it? Simply in the place of x you will write 1. Okay, here in the place of x you have 1, so here also in the place of x you will substitute 1. Okay, so this is nothing but 1 square plus 5 into 1 plus 4. Okay, so this is nothing but 1 square is 1 plus 5 into 1 is 5 plus 4. So this is 10. So p of 1 is 10. Simply in the place of x you will substitute 1. Now what is p of minus 1? So it is nothing but in the place of x you will substitute what? Minus 1. So this is minus 1 whole square plus 5 into minus 1 plus 4. Okay, so minus 1 whole square is nothing but minus 1 into minus 1, it is 1. Plus 5 into minus 1 is minus 5. Okay, you have plus 4. Now this is 1 plus 4 is 5 and you have minus 5, so the answer is 0. So p of minus 1 you got it as 0. Clear? Now 0 of a polynomial is nothing but the value for which the polynomial, the p of x became 0 is called 0 of the polynomial. Here for which value did this polynomial become 0? Okay, for p of minus 1 it became 0. Okay, so this value minus 1 is called 0 of this polynomial. Okay, so 0 of a polynomial is nothing but the value of x for which this polynomial becomes 0 is called 0 of a polynomial, and also this is the solution of the polynomial. Okay, now suppose let us take another example, x plus 2. Okay, let me take this as g of x. Okay, since I took it as p, I am taking it as g of x. Okay, so if I want to find the 0 of this polynomial, firstly I substitute 1. So you can substitute the values in any value for x, okay, and you will check where the value of this polynomial is becoming 0. Okay, you can substitute any value of x and check for which value of this x is this polynomial becoming 0. Clear? So when x equal to 1, this is 1 plus 2 is 3. Now what if x is minus 1? G of minus 1 is minus 1 plus 2, it is 1. Okay, now what if x is 2? So it is 2 plus 2. 2 plus 2 is 4. Now what if x is minus 2? Okay, I am taking one positive and one negative value. So when x is minus 2, it is minus 2 plus 2, it is 0. Okay, so for the value of x, when I have taken x as minus 2, I got this polynomial as 0. Okay, so clearly 0 of this polynomial, the solution of this polynomial is nothing but what? It is minus 2. Clear? So now if you observe simply, what are we getting here? Now if I take x plus 2 equal to 0, now what is x? X is minus 2 plus 2, transposing it to the other side becomes minus 2. Yes, so here you got the 0 of the polynomial simply by equating the given polynomial to 0. Yes, okay, now suppose if I have a polynomial ax plus b. Okay, and I have to find the 0 of this polynomial. Simply using this, you can equate this to 0. Yes, so what is the value of x? Ax is equal to, here it is plus b, sending it to the other side will be minus b. So what is x? X is minus b by a. Okay, a is multiplication, if it goes to the other side it will be division. So x is b by a is the 0 of this polynomial. Clear? So whenever a linear polynomial is given to you, you will just equate it to 0 to get the answer, the solution, the 0 of the polynomial. As we have discussed concepts so far, so let me give you some model problems. Okay, so in the question they may give you p of x is 3x plus 1 and they may ask you to find the value of p of 1, p of minus 1 and p of 2. How do you do that? Simply you will substitute 1 here. So 3 into, in the place of x you will write what? 1 plus 1. So 3 into 1 is 3 plus 1 is 4. Yes, so simply in the place of x you will substitute 1. Here in the place of x you will substitute what? You will substitute minus 1. So 3 into minus 1 plus 1. So 3 into minus 1 is minus 3 plus 1, it is minus 2. Okay, now p of 2 is nothing but in the place of x you will substitute 2. So 3 into 2 plus 1, it is 3 2s are 6 plus 1 is 7. Clear? So very simple, if they ask you to find the values in this way, you will substitute the given value, x value in this polynomial. Now if there is a polynomial 2x plus 1 and you have to find the 0 of this polynomial. Okay, so take p of x is 2x plus 1. Okay, so we have learned that to find the solution, the 0 of this polynomial, you can just equate the given polynomial to 0 and find the value of x. Yes, so here 2x is equal to plus 1, if it goes to the other side it is minus 1. So x is equal to minus 1 by 2. So x equal to minus 1 by 2 is the solution of this polynomial. Okay, so you can even substitute here and see 2 into x is minus 1 by 2 plus 1. Okay, so this is 2 1s are 2 1s are, so it is minus 1 plus 1, so this is 0. Clear? So substituting x equal to minus 1 by 2, this polynomial is, the value of this polynomial is 0. So this is 0 of this polynomial. Now another model of question you may get is, now this is the polynomial and 3 is the 0 of this polynomial. Okay, so x square plus 2x minus a is a polynomial and 3 is the 0 of this polynomial. So you have to find the value of a. Okay, so since it is given that 3 is the 0 of this polynomial, which means now if this is p of x equal to x square plus 2x minus a, so for the value of 3, this polynomial is 0. Yes, this is nothing but 3 is the 0 of the polynomial. Okay, now what is p of 3? P of 3 is nothing but substituting 3 in this place. Yes, so it is nothing but 3 square plus 2 into 3 minus a equal to 0. Okay, so 3 square is 9 plus 2 into 3 is 6 minus a equal to 0. So 9 plus 6 is 15 minus a is 0. So a is nothing but 15. Clear? So simple, this polynomial is given to you and they told that 3 is a 0 of this polynomial, okay, which means if this is p of x, then p of 3 will be 0, as we have learned the concept of 0 of polynomial. So p of 3 is 0, okay. So substituting p of 3 is nothing but you will substitute 3 in the place of x. So it is 3 square plus 2 into 3 minus a is 0. Okay, so solving you get the value of a. Is learning polynomials interesting? Yes, let's make it even more interesting by solving these yourself. Okay, so do it yourself. Find degree of 4x power 5 plus 7x minus 2. Find p of minus 2 for this polynomial and find the value of a if 2 is the 0 of the polynomial of this polynomial. Okay, so do all this yourself and mention the answers of these questions in the comment section below. This brings us to the end of this video and I hope you are very clear with the basic concepts of polynomials now. So do like this video and share this video to all your friends and don't forget to subscribe to the channel. Subscription is free of cost. Thanks for watching.